This is geometry. This is day 6. We're talking about proving triangles congruent using SSS, which is side, side, side. It's an investigation that we can do putting different pieces together, which are straws, and showing that when congruent parts go together, their angles are going to match, their sides are going to match, even if we only start with having 3 bits of information. In the past, we've had 3 angles and 3 sides, and that's how we proved polygons congruent. The question is, can we prove triangles congruent with less information? One way is to start out with just 3 sides. If I give you 3 measurements, for example, maybe a 3, 4, and a 5, a 3-inch side, a 4-inch side, and a 5-inch side. If we start out with those different measurements, everyone would make the same exact triangle out of those shapes. They'd have the same angle measurements, they'd have the same perimeter, the same area. Everything would have to be exactly the same if everybody made a triangle 3, 4, 5. In this case, if side AB mapped with RS and BC with ST and CA with TR, if we have 3 sides that match in one triangle with 3 sides of another triangle, then we know that those triangles have to be congruent. The order matters. The A went to the B, which up the 1 ticker, down the 2 ticker side, and the 3 ticker side. I have to go in the same corresponding order. RST. If you remember the concept of reflexive property of congruence, that's if you have an angle, it's going to be congruent to itself. Or if you have a segment, it's going to be congruent to itself. If we're going to talk about a pair of triangles, here we have 9 for one pair of sides. So they both have an S, which they both have a 9. They both have an S, or another S, which is 8. What we don't know quite yet is, do we have the 3rd side congruent? And we notice that the 3rd side, this LK side, is being shared between the 2. That's called the reflexive property. I know that LK has to be congruent to LK. So, is this congruent statement true? J, K, L. J to K is 8. K to L is the reflexive side. And L to J is 9. That has to match this. M to K, which is 8, the reflexive side, and 9. M, K, L. So the answer is yes. By side, 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 congruence. We know that the triangles are congruent to each other because they have 3 pairs of sides of one triangle congruent to 3 sides of another. Let's try the second one. Notice that we have 2 sides the same with 2 tick marks. We have another pair of sides the same with 3 tick marks. What we don't know is, do we have any other bits of information? Do we have a reflexive property? Do we have vertical angles? Do we have a midpoint? Anything like that, that would be helpful to know. And we're going to say that we don't. We don't know if RS, which is not labeled, is that going to be congruent? We don't know if it's congruent to TV. We don't know. So we cannot say that the triangles are congruent if we don't have SSS. Right now, that's the only format that we can prove triangles congruent, is side, side, side. In the future, we're going to learn some other methods also. Are these triangles congruent? At first glance, it looks like they both have a 1 ticker, they both have 2 ticker and 3 ticker, so it does look like the triangles are congruent. But if you look at your congruent statement, has that been written correctly? D to F has 2 tick marks. The first 2 letters here, H to K, have 1 tick mark. So it's not written in the correct order. So we would say, no, this congruent statement is incorrect. Remember the directions. Decide whether the congruent statement is true. It is not true, but triangle DFG would be congruent to triangle HJK. Notice the order was incorrect. The order matters. The corresponding sides have to match up. The first 2 letters, F or DF, have to correspond with the first 2 letters, HJ. Second 2 letters, FG, have to correspond with the second 2 letters, JK. And the first and last with the first and last. With this pair, the 2 triangles, they both have 7s the same, so we can put 1 tick mark on those. They both have this reflexive property, so we can make both the same on those, but it clearly does not have a 3rd pair the same. Is the congruent statement correct? No. AB is not congruent to DC. This is a D. On the next side, we're given triangle ABC. So we label our triangle. We're also given another triangle at 2, -2, which is D, 4, -2, which is E, and point F is at 2, -6. We have these 2 triangles. The question is, use the coordinates to determine if they're congruent. Well, what makes 2 triangles congruent? Right now, the only methods that we know is SSS, which stands for side, side, side. I need to see if all the corresponding sides match up. What's the length of AB? AB is vertical. We can count that. So AB equals 2. DE is horizontal, but we can still count that. DE is 2. So I know that AB is congruent to DE. Let's look at the first and last, which is AC. AC has a length of 4. DF has a length of 4. That's the first and last. So I know that AC is congruent to DF. Notice with our notation we have to put the segment lines above the letters when we talk about segments with congruence, but we don't use the segment bars when we're talking about the measure of their length. Now, the part that we're not real sure about is a slanted amount. BC and EF, they're slanted. We can't count that. So we're going to have to do the distance formula. So BC, -5 minus -1 squared, and 3 minus 1 squared, -5 plus 1, quantity squared, 3 minus 1 is 2, -5 plus 1 is -4, which is 16 plus 4, which is a square root of 20. The length of EF, using the distance formula, is 4 minus 2, and -2 minus -6. That gives us 2 squared, and a negative, minusing that negative, gives you plus 6. 4 plus 4, well, it's 4 plus 4 squared, which is 4 plus 16. You can't add the 4's together, so that gives you the square root of 20. These are the same. So we now know that we have BC congruent to EF. So now we can say that the triangles are congruent. Triangle ABC is congruent to triangle DEF. The order is correct because it's going from the biggest angle down the shortest side, down the longest side, and down the medium side. Same thing on that. When you're setting up a proof in geometry, it's important to make a plan before you start writing. In geometry, a lot of our proofs that we do for proving triangles congruent, we're going to do from scratch. We're going to have no help along the way. Look at the given information. We know that WX is congruent to YX because of the given information. We know that Z is a midpoint. So if you have a midpoint, you need to know what that actually gives you or what that means. If Z is the midpoint, then we're going to have two congruent segments. Looking at our information that we have here, we have two sides of one triangle congruent to two sides of another. Do we have any other information about these shapes? If we look at the picture some more, we see where we have a reflexive property. Now I could do side, side, side of one triangle matches side, side, side of another triangle. That's my plan. You got to decide if it's possible before you start your proof. So we're starting with our given information. Those are our segments. We also know that Z is the midpoint of YW. That's also part of our given. From our midpoint, now we can state that WZ is congruent to YZ. How can we come to that conclusion? If midpoint, or if we have a midpoint, then two congruent segments. That'll be formed whenever you have a midpoint. Two congruent segments. We also have the reflexive property of equality, which makes those segments the same. They're both sharing the same segment, so we know that that segment is the same length in both figures. We call that the reflexive property of congruence, because it's a congruent symbol. And our last is triangle WXZ is congruent to triangle YXZ. Currently, we only have one way to prove triangles congruent, but eventually we'll have four. Right now, side, side, side congruence, because we showed one pair of sides the same, another pair of sides the same, and a third side. Looking at our last proof, again, make your plan before you start to fill out your proof. IJ is congruent to HK. IH is congruent to JK. That's all our given information. Looking at our figure, how could we get another bit of information to help us show the two triangles are congruent? We would see that JH is the reflexive property. It has to be the same in both shapes. Then we have three sides of one triangle matching three sides of another. IJ is congruent to HK, and IH is congruent to JK. Those are two sides, and that's all part of our given. The other part of information that we know for sure is that JH is congruent to HJ. That's the reflexive property of congruence. And that's going to leave us with our last statement of HIJ being congruent to JKH. Side, side, side congruence.